We now move to application of differentiation. Before that, under application of differentiation, we have first one we have concept of maximum and minimum. Under concept of maximum and minimum, we first talk about stationary point. Now the definition. If they say that a point is a stationary point, from the word stationary, something that is not moving. So it simply means if the derivative of a function is 0 at a certain point, then that type of point is what we call stationary point. We say that a point s is equal to a. This point is called a stationary point if the derivative of f of s at s is equal to a is 0. What that simply means is that a point at which the y ds is 0, that type of point is what we call a stationary point, or we call it turning point. He said that we call it stationary point or turning point, something like this. So this is a turning point. At that point, the y ds is 0. Now, in order to find stationary point, we only need to differentiate the function, then we equate that derivative to 0. For instance, now we have to find stationary point of this function. To find the stationary point or the turning point, the first thing is I will differentiate. I'll find the y ds, and if I differentiate x squared, I will have 2x plus, if I differentiate 2x, I will have 2. If I differentiate this, I will have 0. So this is the differentiation. To find the stationary point, I will just equate this thing to 0. I will just say that 2x, that's my answer, is equal to 0. From this place, if you take this to the other side, we have minus 2. So if you divide both sides by 2, then s is equal to minus 2 over 2, which is minus 1. So this s is equal to minus 1 is our stationary point. That is how to find stationary point. You only need to differentiate, then equate it to 0. Any answer you get there is a stationary point. So therefore, our stationary point is minus 1. We can now move to concept of minimum and maximum. How to find minimum and maximum. So let me see how to find minimum and maximum point. The first thing is to find minimum and maximum point. We only need to consider these two steps. The first step is we find the stationary point that we explained there. And how do we find stationary point? Find the y ds, equate the y ds to be 0 so that you get the value of x. That is how to find stationary point. The first step is find stationary point. The second step is differentiate the function once again. For instance, now here I'll differentiate once again. You differentiate the function once again. So that is, you need to find this sign d square y over ds square. It simply means second derivative. That is, you differentiate dy ds once again. So that is what they mean by d square y ds square. So having done that, we can now move to how do we now find the minimum and maximum. If you have followed these two steps, then you look for the condition. These are the conditions here. The first condition is that second derivative that you find, if it is less than 0, that is, if it gives you negative, that is, that second derivative if it gives you negative, then that stationary point that you found here, this stationary point that you found in this step 1 here, so we say that that stationary point is the maximum point. And if the second derivative is greater than 0, simply means it is positive, then that stationary point is called the minimum point. While if that second derivative is equal to 0, if it gives you 0 directly, then we say that the stationary point that I found is what we call point of inflection. Now let's take example to buttress this. Example 2. Find the minimum and maximum points and minimum and maximum values of this function. You observe that we are finding minimum and maximum point, minimum and maximum value. Now the first thing, to find the minimum and maximum point, find the stationary point. That is, differentiate this. If I differentiate that, I will get 3s squared minus 12. That's the first step. And for this, we will equate it to 0. So that we have 3s squared minus 12 is equal to 0. S squared minus 4 is equal to 0. We have divided both sides by 3. 3 can go in 12. 3 cancel 3, we have s squared. 3 cancel 12, we have 4. Then s squared is equal to 4. We take minus 4 to the other side, so that s is plus or minus square root of 4. When this square comes here, it becomes square root. So our answer is plus or minus 2. So what we have found is our stationary point are plus 2, and the second one minus 2, plus or minus 2. So those are the stationary points. Now, how do you now know whether these two stationary points, whether they are minimum or maximum? We don't know. We now need to differentiate once again. Step 2, we differentiate once again like this. This is our first differentiation. Our second differentiation is you differentiate this once again. That is the meaning of this. And that will give me 6x. If you differentiate 12, that is 0. Now, let me test this. You substitute these values. We substitute these values. If we can't know whether this thing is positive or negative. We don't know. Let us just substitute these values. If I substitute, I'll first say that if s is 0, what will happen? That second derivative will be equal to 6 times 2. We put s to be 2, and that is 12. You see that it is greater than 0, or we say that it's positive. And we say that if the point is positive, therefore that stationary point s is equal to 2 is the minimum point, because it gives second derivative gives me positive. We test the second one to this one. We say that if s is equal to minus 2, the second derivative is 6 into minus 2. So our answer is minus 12, which is, this one is less than 0, or we say that it's negative. Minus 12 is negative. Therefore, we can now say that s is equal to minus 2 is the maximum point. But what they ask us to find, we have to find minimum and maximum point, which we have found. The minimum point is 2. The maximum point is minus 2. Now the second one says find the minimum and maximum values. If they say that you find the minimum and maximum values, you now substitute these 2 points inside the given function. So we continue. We say that our given function is y s cubed minus 12s plus 3. Now let me find minimum value. Minimum value will now be equal to, anywhere I see s, I'll put it as 2. Why do I put it as 2? Because s is equal to 2 is the minimum point. So we use minimum point to get minimum value. So 12 into 2 plus 3. So 2 raised to power 3 is 11 minus 24 plus, this is 8 plus this 11. 11 minus 24, we have minus 13. So the minimum value is minus 13, which we can write as 2 comma minus 13. So the next thing is maximum value. We know that s is equal to minus 2 is what? Maximum point. So I only need to substitute. Whenever I see minus 2, I'll put it here, so that we have minus 2 cube, this one, minus 12 into x, which is minus 2 plus 3. So our answer is, this will give me minus 8 plus 24 plus 3, and that will give me 19. Therefore, I can say that maximum value is equal to 19, or I can write it as minus 2 comma 19. So this is the minimum point and this is the maximum point. 19 is maximum value. So let's take another example. Another example, determine the minimum and maximum values of this curve. Now, to get that, our first thing, we differentiate the y dx. And if I differentiate s cubed, I will have 3s squared minus, if I differentiate 6s squared, I will have 12x plus, if I differentiate 9x, I will have 9. But if I differentiate this, I will have 0. So in that case, that's the first step. Second step is we substitute, we equate this thing to be 0. Now, observe that 3 is common to this. So if I cancel this, I will have s squared minus 3 cancel here, we have 4s plus 3 cancel here, I will have 3, which is equal to 0. So this one leads to quadratic equation. Now at this level, I don't think I should be explaining quadratic equation for you. When we solve the quadratic equation, we are going to have that s is equal to 1 or s is equal to 3. That's the solution of this quadratic equation. So this s is equal to 1, the stationary point are s is equal to 1, s is equal to 3. Now out of this stationary point, one is minimum point and one is maximum point. So we don't know. How do we know? We differentiate once again. We find this, the square y dx squared. If I differentiate once again, let me just, this is the first differentiation. It is this one that I'm differentiating once again, and that will give me, if I differentiate this, I will have 6x minus, if I differentiate this, I will have 12. Now, as usual, I need to test this one, whether it will give me negative. I'll start by saying if s is 1, the square y dx square equal to, anywhere I see s, I'll put it as 1. This is 6 into 1 minus 12. This is 6 minus 12. This is equal to minus 6. This is less than 0. So you observe that we have negative here. Therefore, I will say that s is equal to 1 is the maximum point. Also, if s is equal to 2, the square y dx square is equal to 6 into 2 minus 12. So if you put this, all we have there is not 2, it's 3. This is 3. 6 times 3, 18. 18 minus 12, that is 6, is greater than 0. Therefore, s is equal to 3 is the minimum point. Because s is equal to 3 gives me positive here. S is equal to 1 gives me negative. That is why this is maximum point. But that's not what they ask us to find. What they ask us to find is maximum and minimum value. Now let us now find minimum value. So we use minimum point. These are minimum point to get minimum value. And how do we get it? We substitute this in the given function. This is the given function. So in that case, our minimum value will be equal to, we'll be using the function s cube. That will be 3 cube minus what we have there, 6 into 3 squared plus 9 into 3 plus 1. You come back to your function. Anywhere you see s, you'll be putting it as what you got. So if I simplify this now, this is 27 minus this plus another 27 plus 1, it will give me 1. So in that case, our minimum value is 1. So which I can write as 3, 1. Also, the maximum value. So we got that using s is equal to 1. Because s is equal to 1 is our maximum point. So we are going to substitute inside that place. So our y is equal to 1 cube minus 6 into 1 square plus 9 into 1 plus 1. Anywhere you see s, I'll put it as 1 here. So when s is equal to 1, I have 5. In that case, the maximum value is 5. So which I can also write as 1, 5. So this is the maximum value, and this is the minimum value of that function. Now move to application of differentiation to business and economics. The first one is marginal concept. Under that, for any time you hear the word marginal simply means dy dx, differentiation, or we can call it slope. For cost function, marginal cost means differentiation of cost function with respect to the quantity. And for revenue, marginal revenue simply means differentiation of revenue function. Anytime they mention marginal simply means differentiation. If I say that marginal profit, it simply means differentiation of the profit. That is the application of differentiation. Now, this is elasticity of demand. The formula for elasticity of demand is price over quantity times 1 over times the Q dP. The Q dP simply means 1 over the P dQ. Simply means 1 over the slope, and that is differentiation. The P dQ means differentiation of price with respect to quantity. Also, another important thing which we should note is that profit simply means total revenue minus total cost. And number 4, break-even point is a point at which total cost is equal to total revenue. Point we get when we equate total revenue to total cost, when they are equal to each other. That point is called break-even point. Also, we talk of maximum profit. Maximum profit also occurs when marginal cost is equal to marginal revenue. And you know marginal means differentiation. Another thing is revenue simply means price times quantity. And the last one here, equilibrium point. That one occurs when quantity demand is equal to quantity supply. We should take note of all this. Now let's take example. Example 1 here. The cost function of a commodity is given as this: TC equal to 4P square plus 3P minus 1. Find the marginal cost when Q is 6. To do this, marginal cost simply means I should differentiate. I will not write it like this. This thing over the Q, over the P. We are dealing with P there. So that is D, whatever that is here, over D, whatever that is here. That is simply means I should differentiate this. If I differentiate this, the price is this. If I differentiate this, I will have 8P plus, if I differentiate this, I will have 3. Now, we are told that P is equal to 6. When P is equal to 6 simply means anywhere we see P, we put it as 6. Our answer. Therefore, I can say that marginal cost is equal to 8 into P. Our P is 6 plus 3. 8 times 6 is 48. 48 plus 3, that should be 51. So in that case, the marginal cost is equal to 51. So this is another example. Find the marginal revenue. If the revenue function is this, how do you find the marginal revenue? I will just differentiate this function. I will differentiate this function. If I differentiate it, I will have, if I differentiate this will come down. 3 times 3, 9. 9Q square minus 8Q plus 2. If I differentiate this 7, I will have 0. So this is the marginal revenue. So what we want to gain here is that anytime we hear the word marginal, it means differentiation. As you can see that we differentiated this to get marginal cost, and we differentiated this to get marginal revenue. Let's take another example. Example 3. Find the marginal profit if the cost and revenue are given as this. So this is the cost, this is the revenue. This is a cost function, this is revenue, but they ask us to find marginal profit. How can we find marginal profit when profit is not given? We are only giving cost and revenue. But we need to recall from what I've given you that profit is equal to, let me use P for profit. Let me use P for it. Profit is equal to total cost minus total revenue from what I gave you the other time. This is a profit is equal to total revenue minus total cost. Total revenue minus total cost. Now, what's our total revenue? This is our total revenue here, which is let me use P for profit. 2Q cubed minus 7Q squared plus 5Q plus 6 minus total cost. This are total cost. 4q cube minus this minus will affect this, or let me put it like this, minus 2q square, which at the end of the day will give me 2q cube minus 7q square plus 5q plus 6 minus this minus will affect this, which become 2q square. Finally, our p here will now be 2q cube minus 4q cube. We have minus 2q cube. Also, minus 7q squared plus 2q squared, that will be minus 5q squared plus this 5q plus 6. But what are we looking for? Marginal profit. We have successfully found the profit. Marginal profit, it simply means I should differentiate this. I'll write it like this: the p over the whatever that is here, the q. So that is, let me use PR. So if I differentiate this thing, I will have minus 6q squared minus, if I differentiate this, I will have 10q plus, if I differentiate 5q, I will have ordinary 5. If I differentiate this, I will have 0. So this is our answer. So this is marginal profit. So I've used total cost and total revenue to get the profit. And when I got the profit, I now found the marginal profit. Now, the total cost and total revenue functions of a product are this and this. This is a cost and this is a revenue. Find the maximum profit of the function. To get the maximum profit, we need to know what is profit itself. And we have known that profit is total revenue minus total cost. The total revenue is there, 2q cube minus 3 plus 3q square plus 12q minus total cost 4q cube plus, it will now become minus now. Because of the minus here, it will affect this plus, minus 6q squared. So that our profit will be equal to, let's subtract 2q minus this, that is minus 2q cube. This minus this, we have minus 3q squared, and we have 12q there. So this is what we have. Now we are not dealing with maximum profit. This is example of minimum and maximum that we treated earlier. How do we find minimum and maximum? We first find the stationary point, that is, we differentiate the PR, the Q, we differentiate this. If I differentiate, I will have minus 6q squared minus, if I differentiate this, I will have 6q. If I differentiate this, I will have plus 12. So after this, we normally equate it to 0. We say minus 6q squared minus 6q plus 12 equal to 0. Observe that minus 6 is common. If I divide this one by minus 6, it will remain q squared. If I divide this one by minus 6, it will remain q. And if I divide this one by minus 6, it will become minus 2, which is equal to 0. This is quadratic equation. So I don't need to teach you quadratic equation here. If you solve it, you see that q is 1 or q is equal to minus 2. And whatsoever, we cannot use this. Q cannot be my quantity, because q here is representing quantity. It can never be minus 2. So this is what we are using. So we don't need to differentiate once again. So since we have noted that our q is 1, in that case, anywhere I see q now, substitute it here. I can now say that therefore my maximum profit is equal to, anywhere I see q, I'll put it as 1, minus 2 into 1 cube minus 3 into 1 square plus 2 into 1. This is minus 2 minus 3 plus 12. And this will give me 7. So in that case, the maximum profit is 7. That is, the maximum profit of the quantity that is having this is 7. Now, another example. Find the marginal revenue of a product whose price is given as this at q is equal to 4 units. We have to find the marginal revenue, but marginal revenue is not given here, but we can find the revenue itself. When revenue is given, that is when we can find marginal revenue. But here, what we are given is just price. But what we should know to get the revenue, we know that revenue is price times quantity. So in that case, our revenue is, the price is given here to be 2q square minus 3q plus 2 times, we use q for the quantity, so that my revenue is 2q cube minus 3q square plus 2q. If I use q to multiply, this times this, this times this, this times this, from that place I cannot find the marginal revenue. Marginal revenue simply means I should differentiate this revenue function. That's the meaning of marginal revenue, and we have been doing that. This is how we write the differentiation, dr dq. If I differentiate this, I will have 6q squared minus, if I differentiate this, I will have 6q plus, if I differentiate 2q, I will have 2. But we are told that q is equal to 4. Anywhere I see q, I'll put 4. This will be 6 into 4 square minus 6 into 4 plus 2. 4 square is 16. So 16 times it, everything will give me 74. So that means 74 is the answer to this. Another example, the demand function and supply function for a commodity are given as this. So that means this is demand, this one is supply. Determine 1. Equilibrium point, 2. Elasticity of demand at q is equal to 10. The first one, equilibrium point. So that is when quantity demand is equal to quantity supply. When demand is equal to supply, we have equilibrium point. So equilibrium point there, I will just equate this and this. That is 36 minus 6q is equal to 10q minus 8. So from this, we are going to have 10q plus 6q is equal to 36 plus 8. So this will give me 16q is equal to 44. Finally, our q there is equal to 44 over 16. 4 can go, that is 11 over 4. So that is the equilibrium point. So to get the equilibrium price, anywhere I see q, I'll put it anywhere. I'll use any of these two that I like. So we know that p is equal to, you choose any of the two. So if I decide to choose 10 minus 10q minus 8, anywhere you see q, you put q to be 11 over 4 minus 8. And 11 over 4, this cancel this, something can still go here. So we should be able to have 55 over 2 minus 8. If I find the LCM there, we have 55 minus 16 over 2. And 55 minus 16 give me 39 over 2, which is 19.5. So in that case, we can say that equilibrium point is given as p comma q 19.5 comma 11 over 4. We can use calculator to do that. So that is the solution. Also, we have to find elasticity of demand. Let us first know that our demand function is given as these are demand function here. 36 minus is given as 36 minus 6q. The zq is equal to 10. Let's know that elasticity of demand from what I gave initially. From the formula I gave, I said that elasticity of demand is this. You can see this is a formula once again. Elasticity of demand is P over Q into the Q dP. Now, our P is given as 36 minus 6Q. Let's differentiate. It's application of differentiation. dP dQ. If I differentiate this, I will get 0. If I differentiate then minus, if I differentiate 6Q, I will get 6. That is our dP dQ. But what is inside this formula is dQ dP. So I will now say that dQ dP, you only need to interchange. This is over 1. I will say that minus 1 over 6. You only need to take this up, bring this down. Because I am bringing this up, bringing this down. So that is our dQ dP. Therefore, our elasticity of demand will now be price over quantity. This is our price is given over Q times dQ dP. These are the Q dP minus 1 over 6. And that will give me 6 cancel 6. 6 here, 6. 6 cancel 6. All we have left is 6 minus Q over Q. There is minus there. There is minus 1 left. So the minus will affect this one. So that we are going to have Q minus 6 over Q. Instead of 6 minus Q to be, instead of 6 minus Q to now be Q minus 6 because of this minus. But now we are told that Q is 10. When Q is 10, that will be 10 minus 6 over 10. And 10 minus 6 is 4 over 10. Therefore, elasticity of demand is equal to 0.4, which is very low. It's lower than the half. So elasticity of demand is 0.4, or we consider 40%. So this simply means that the product is elastic. What do they mean by elastic there? It means that if there is a change in price, people will not patronize the product. When elasticity of demand is low like this, that means that if you change the price of such commodity, people will not patronize it, and that simply means the price is elastic. And if they say the elasticity of demand is just it simply means the degree of responsiveness of consumer to a product due to small change in price. That simply means that if there's a change in price, we want to measure the degree of responsiveness. That is, we want to measure how people will respond to the commodity. If there's a change in price, if there's a small change in price, we want to see. And if the product is inelastic, because this one is elastic because we have a very low percentage, 40%. So that means it's elastic. If the something is inelastic, that means we are going to have high elasticity of demand. So that means the product is inelastic. That is, even if you change the price, people will still buy it. For instance, price of petrol now, even if we change it to 500 naira, people will still buy it. The number of people that are buying it before will still be the number of people that are buying it. That means it is inelastic.